Welcome to the wonderful world of transformations of functions. We're going to take a look at 4 transformations, both vertical and horizontal, stretches and shifts, and let's dive right into it. Now we're going to look at 4 different types of transformations. The vertical shift, as it's called sometimes, that can be found outside of the function, adding, as highlighted there by the letter D. Translation, or sometimes known as horizontal shift, which is denoted by that letter C. Compressions, which is outside of the function multiplying, as seen by the letter A, and or compressions, which can be found multiplying inside of the function as the letter B. Now, some places you may see different letters used, but the position of the letters is the most important thing. First, let's take a look at vertical translation. Here we have our parent function x squared. We're going to be using that to demo most of our transformations. Consider the parent function of the parabola. F of x equals x squared. Shift or translate the curve upward along the y-axis by 2 units. If we add a constant number d to the function, we translate it upward if d is more than 0, or downward if d is less than 0, along the y-axis by that amount. So let's see what this looks like. As you can see, it shifts up. If we shift down too. So that's what it means by d greater than 0. It just means any positive number makes it go upward. And with d less than 0, that means any negative number makes it go down if you're adding it on the outside. Horizontal translation, the C. When a number, usually denoted by C, is subtracted from the independent variable inside of the function is translated by C units to the right if C is more than 0, and to the left if C is less than 0, which is a fancy way of saying x minus C goes to the right and x plus C goes to the left. This can be tricky. Remember that the transformation is written in the form f of x minus C. The C is subtracted. So when C is positive, the translation is in the positive x direction. And when it's negative, it's x minus C, which looks like x plus C. And the translation is to the left. For example, f of x equals x minus 2 is a parabola translated to the right 2 equals x plus 2 squared is a parabola translated to the left by 2 units. So if you see x plus something, it's to the left. If you see x minus something, it's to the right. Now let's take a look at vertical stretches and compressions, as denoted by the variable a. Vertical stretches and compressions is when a function is multiplied by a constant. It's usually denoted by a. The result is a vertical scaling of the graph. In this case, f of x becomes a f of x. Example, we've made a 2. So you're doing 2 times x squared. When a is more than 1, the graph is going to be stretched vertically. Or I should say between 0 and 1, it's compressed. The reason why I don't just say less than 1 is because what the negative, so this is a negative x squared. So the negative does not stretch or compress it, it flips it. Okay? So if I had a negative number that was greater than 1, it would be flipped and stretched. If it was negative 1/2, it would be flipped and compressed. Now when I say flipped, I'm talking about reflecting it across the x-axis. horizontal stretches and compressions as denoted by the letter B in the equation above. When the independent variable is multiplied by a constant, usually denoted by B, the result is scaling of the graph along the x-axis. Now this is a little bit flip-flopped with the vertical stretch and compression. When B is a small number, and when I say small number I mean between 0 and 1, the graph is actually stretched horizontally. It's made wider. Half x squared makes the graph stretch horizontally. 2x squared makes it compress horizontally. So whenever you have a big number, and when I say big number I mean number bigger than 1, it's going to compress. When you have a small number for B, it's going to stretch. Now what the negative does is it flips it. It's a little bit difficult to see with the quadratic graph, so we're going to take another look at this on the cubic graph. Now x cubed, this is our parent function. If I do a negative x cubed, it flips it horizontally. We are doing transformations of functions. Here is our basic transformations. We're going to go through these one at a time. First thing I want to know is that everything on the inside is a horizontal transformation. So B and C are both horizontal because they're considered to be inside the function. A and D are considered to be vertical because they are outside of the function. So we know that inside is horizontal, outside is vertical. Now let's look at what each of these are doing. It represents shifts. So C is inside the function, which makes it horizontal, and it's subtracting, which makes it a shift. C is a horizontal shift. D is outside of the function, which makes it vertical, and it's adding, which makes it a shift. So D is a vertical shift. Applying is stretch and compression. So B is inside the function and multiplying, so it's a horizontal stretch or compression. A is outside of the function, vertical, and it's multiplying, which makes it a vertical stretch or compression. So let's take a look at these a little bit more detail. A, as we mentioned, is a vertical stretch or compression. If it's more than 1, it's a stretch. If it's a small number between 0 and 1, it's a compression. And if it's negative, it's a vertical flip. B is a horizontal stretch or compression, as we mentioned. Only small numbers make it stretch and big numbers make it compress. Again, if it's negative, it makes it flip. C is on the inside and it's subtracting, so that's horizontal shift. Just remember that if you have x plus C, it's being shifted to the left, and if you have x minus C, it's shifting to the right. D is on the outside and it's adding, so it's a vertical shift. It does what you think it would do. If it's greater than 0, it's going to shift upward, and if it's less than 0 or negative, it's going to shift downward. So this is probably the most important part that you need to note. Make sure all of this is in your notebook. Take a screenshot. This is the part that you study that kind of summarizes everything. All right, I'll catch you in the next video.